Number 30 is the multiplication of complex numbers, and if you multiply two complex numbers together, you have to know how to add and subtract as well. So really, multiplication is kind of the heart of it all, because even division is just nothing but multiplication. So that's how this works. This 30 and 31, we're going to go ahead and just go to these. This is using a process which we would normally just call FOIL. Remember, you do the first, and then you do the outers. Okay, and then you do the inners, and then you do the last. Okay, so remember, FOIL is just a way to multiply two binomials together. Binomial just means two terms. Alright, so do your firsts. 5 times 2 is just 10, and what we do is we just make a string here, and we're going to just add the ones that we can that are considered like terms. So the first, okay, then you do the outers, which is 5 times I, which is just 5i. And then you do the, yeah, my kids are running around like banshees today, so I'm just going to ignore them. Then we got negative 3i times 2, that's negative 6i. And negative 3i times I is negative 3i squared. Alright? Now we've done enough of these, hopefully, that you remember that this basically, remember what's great about I is it can only, when you raise him to a power, he can only change to I, negative I, or 1, or negative 1. Like, that's it. And in this case, when I is squared, he just becomes a negative 1. Now, a negative 1, when you multiply something, is just a sign changer. So let's just put plus 3, alright? Because a negative 3 times negative 1 gives us positive 3. Now, what that does, it allows us to just add those two immediately for 13. And then these guys will always combine together for a negative I, because 5 minus 6 is negative 1, and the I just follows along for the ride. So our final answer is just 13 minus I. Now, multiplying two complex numbers gives you a complex number. That's how it's supposed to work. You should not get I squared or I to the third or anything else. Alright, you should get another complex number. Now, sometimes the i's might cancel out, sometimes the real numbers might cancel out, but that, you know, we'll just take it as it arrives. Alright, so let's look at this guy. So first we do the firsts. Okay, well, I missed that by a mile right there. So negative 3 times 2 is just negative 6. Negative 3 times negative 3i is just a positive 9i. And then a positive 2i times a positive 2 is positive 4i. And then a 2 negative I squared. Okay, so you'll notice then that these guys here, that right there is positive 6 because of the sign change. Now you'll notice that that is also negative 6. So what happened, what I just mentioned earlier, is that these guys actually cancel themselves out. Now it's still a complex number, it's just that what's left is just the imaginary part. Okay, that's the only thing that's left. The real part got canceled out. Okay, now remember that if we graph these, 13i would just be way up here. Okay, that would be 13i. 13 minus I would be 13 all the way over here, and then you would have to drop 1. Okay, that would be 13 minus I. So another interesting thing about complex numbers is that they are not ordered, which is kind of strange. We can always go 0, we can go to infinity, right? We know the order, we know that one is less than the other, but unfortunately, when you have this number and that number on the complex plane, this guy is not this is not greater than this number. It's kind of a weird place to be. Anyways, let's move forward with 32. We'll just make this video once, so I'll put this flickering. Let's see, we got 5 divided by 3 plus I. Okay, we're not allowed to have i's in the denominator. That's just kind of the practice. What is the reason for that? The reason is no one keeps the I in the denominator. It's just kind of a you want to make this into a value, a complex number that has an imaginary and a real part, and you can't do that when you have I in the denominator. You have to put him in the numerator to see what fractions you have. I'll explain, or I'll demonstrate. Okay, so what we've got is we got two instances of multiplication. So we will go 5 times 3. Now I'm just going to focus on the numerator first, for no other reason other than because I can. 5 times negative 1 is going to be 5i, negative 5i. Alright, now if you remember, I chose 3 minus I here because it is the conjugate of the denominator. So these two are conjugates to each other, and they do something when you multiply that others don't. Alright, now each value here only has one conjugate. Alright, conjugates are unique to each other. Okay, so now we got 3 times 3 is 9, 3 times negative I is negative 3i, I times 3 is just positive 3i, and then I times negative I is just negative I squared. Alright, so what happens then is that these guys cancel out every time, and we have a 9, and that actually is a plus 1, because a double negative means that it is positive. So 9 plus 1 is 10, so we get 15 minus 5i over 10. Watch out for this, because you might not see this as a possible answer. Everything can be divided by 5. Now all three terms have to have a common denominator for us to make this work. Okay, so because essentially what you have, I don't want to show you. Let me do this first. 5 will go into each, so that's I, and then 5 will go in there twice. Okay, now what you'll notice if you move higher up into mathematics and you're working with complex numbers is that often what will happen is they will split this up. Okay, and so this has the real part and the imaginary part. Now you can't split these up if you have I in the denominator. He has to be in the numerator to make the complex number in the complex form with the real part and imaginary part. Okay, now this isn't a perfectly suitable answer for us, but if you do go into, again, higher mathematics and you go into electrical circuits and stuff, this is probably how you're going to see it play out. Okay, alright, so moving forward, we're going to do 33, and then at the 7-minute mark we will stop. We're going to troubleshoot number 34 though too. We'll throw that in here. Alright, division is always the hardest of the operations. Remember, operations in math is just addition, subtraction, multiplication, and division. Those are called operations. And so you always want to take care with division. Division is the toughest one. It always is complicated. Alright, again, conjugate surfaces here. I multiply two binomials twice. Okay, so we're going to have a long fraction here. And so 2 times 1 is 2. 2 times negative 2i is negative 4i. That's negative 3i. And then that would be a positive 6i squared. Alright, we'll polish that up in a minute. Let's do the bottom one. We get minus 2i plus 2i. And then we get a minus 4i squared. Okay, so now let's clean this up. This is actually a negative 6. And this one is actually a positive 4. Alright, now I can do that immediately. These guys always cancel out. Alright, these two will combine in the numerator. That is a negative 4. This is negative 4, negative 3. That's negative 7i. And then below should just be one number. 1 plus 4 is just 5. And there is nowhere to go with this. Alright, and again, if you ever, this is the same thing. Okay, it's the same thing. So if you ever saw a YouTube video, if you needed to brush up on your complex numbers, they might put this like this. Okay, same thing. They just split the fraction underneath both terms. Alright, fine. Let's go to number 34. We're going to look and see where the error was. So we're going to describe and correct the error a student made when multiplying these. So let's see what happened here. They did the first 2 times 4, and then they did 2 times I, cool, minus 3I times 4, okay, and then they did negative 3I squared, okay, cool. Now they got 8, then they got 2I, they got negative 12I, then they got minus 3I squared, okay. Okay, so right there, you can see that they actually, this is where you would stop if you had an x, okay? If this was 8 minus 10x minus 3x squared, yeah, we're done. We'd leave it. It's just another quadratic. However, when you're dealing with this, notice that they did not turn this to negative 1, which means this should be a positive 3, which means that positive 3 would have been added to it. It would be 11, so your final answer would have been 11 minus 10i. Okay, 11 minus 10i. All right.